Alright, in this video we're going to be talking about another characteristic of functions, and again, we're only responsible for two, linear and exponential, but this definitely applies to every other function. So domain and range. Domain's your x values, range is your y values, and just to make sure you're clear, on a graph, your x values are on this axis, your y values are on this axis, so if we're talking the x values, we need to be looking left and right. If we're talking y values, we need to be looking up and down. So, on this function, basically you need to ask yourself what's the least x value and what's the greatest x value, and then same thing for y, least to greatest. We're creating intervals. So what I'm about to show you, and if you don't know this notation, go back and watch my other videos on interval notation and inequality stuff. We need to know whether we're going to be using parentheses like this or if we're going to use hard brackets. And so I'm just going to let you know, again, like we talked about in class, the infinities are always parentheses because that's technically like a figment number. You're never going to make it to that number. It's theoretically a large number, whatever the largest number you can think of, and then it's also the very smallest if you're doing negative infinity. But again, we're never going to reach those, so we can't include those. And as a recap, these brackets mean you can't include numbers. So for instance, on our graph, we don't have arrows, which means the ends of our functions have a stopping point. And since they have a stopping point, we know that it's not going to go on forever, and that forever is where we usually have the infinities. So we shouldn't have infinities on this example. So there's a chance that we could have parentheses, but only if these are open circles. But since these are closed circles, that means we can include the numbers on the graph. There's no hole. So we should be using brackets here. So for our domain, again, you're asking yourself what's the lowest x value and what's the highest. Well, if you look right here, this x value, where that point is, there's nothing further this way. Our function does not cross that line. And as far as our biggest x value, nothing goes further than this point over here. There's nothing further out this way. So it's all between these two blue lines. Well, this blue line is sitting at -8. This one over here on the right is sitting at +8. So our domain, our x values, are anything in between. So anywhere on this red function is a domain value, an x value that I can pull off. And there's infinitely many in between there. So we write it as an interval. We say the starting x value, the lowest one's -8, and we can include him because he's a closed circle. And then our greatest x value is a +8, and we can include him. So basically this is not a point. This is not saying the point -8, 8. This is saying we can include all x values starting with -8 and going to +8. So it's an interval. Alright, you want to do the same thing with range. Well, if you look, we want to find the lowest. Well, this point down here, even though he wasn't drawn in, that point is the lowest point. So again, we're going to just kind of draw us a line. We're going to box in our function. So we can't go anywhere below that. There's no part of our red function that's below that point. Likewise up here, there's no part of our function that is higher than this red point. So we're kind of looking at anything in between. Again, we can pull off any point off of this red, and we need to know what y values we're sitting at. So our lowest y value is -7 down here. And it's a closed circle. It's actually a point on our graph, so we're going to call it -7. And then our highest y value is 4. So we're going to say it's anywhere between -7 and 4, and both of those exist on your graph, so it's brackets. And notice, once I've drawn these blue and green lines on my graph over here, we've kind of encapsulated that red function inside what we look like as a box. And so if you can do that for all of your functions, especially the ones that don't have arrows on them that mean we're going on forever, you should be able to figure out what your domain and range is pretty quickly because you're basically drawing in those boundary lines. Where's the lowest x value? Where's the highest? Where's the lowest y value? Where's the highest? So you just have to figure out what those are. Alright, another example, and again we'll kind of do our boundary lines. So as far as x values you go, we don't have an arrow on this left hand side, so this x value is least, the lowest, so we're going to box it in, so nothing left of that. So we can go ahead and start building our domain. Our domain is going to start at -8, and we can include him because he's a point on our graph, our function. But if you notice over here on the right hand side, this arrow means that we're not only going down forever, we're actually going to the right forever as well. So we're never going to stop. There is no stopping point. And again, that's where we're talking about infinities. So this infinity to the right, we're going to keep going infinitely to the right. So we're going to say, and sorry, I put my 8 backwards. thinking too much ahead. This is negative 8. Now we can pull in this infinity. We're going to say it's going to keep going to the positive infinity. And remember, that's always a parentheses. So as far as we're concerned, this arrow goes on forever down and to the right. So we're never going to reach a number. We're going to reach infinity. And then as far as our range values, our lowest and highest, well, our lowest down here, again, this arrow points to negative infinity. So really, that's our starting value. So we're starting way down at negative infinity, wherever that is, lowest down there. And our highest, though, we do have a highest point right here. There's nothing above that point. So we're going to box in that way at least. So that one is 1, 2, 3, 4, 5, 6. So we have 6, and he's included on the graph. So any value between negative infinity down here, this figment number, all the way up to positive 6, because we can't go above positive 6. All right, this one, domain. We have arrows on both ends this time. That means we're going to the left and up forever, and we're going to the right and up forever. So as far as our x values go, we're starting way over here at negative infinity, theoretically, and going all the way to positive infinity. So our domain is all real numbers, basically. So you can either write it like that, or sometimes you'll see it with double bar R, all real numbers. But our range, there is a low point. This is our lowest y value. So even though it's one-sided box, we have a bar we can't cross, and that's at 1, 2, 3, 4, 5. So we can include him. Lowest point on the graph, the lowest y value is negative 5. But again, these arrows point up forever, so we're never going to reach a highest y value. It's just going to be infinity. We're going to keep going until infinity. Alright, on this one, arrows on both ends again. And this is one of the functions you're responsible for this year. So we need domain and range. Domain, obviously, we're pointing to the left and we're pointing way to the right, so it's negative to positive infinity. We're just never going to stop either direction. And this time, we're pointing down forever and we're pointing up forever. So we're pointing to negative and positive infinity for the y values as well. So lines are pretty cool. There's only one case of a line where it kind of messes up, and that's your vertical and your horizontal, your special cases of lines. But as long as they have a slope, a positive or negative slope, pretty much your domain and range is always going to be negative to positive infinity. Go test it out. Alright, and here's your other function you're responsible for. It's got arrows on both ends too, but be careful with this one. So domain, we're pointing to the left forever, we're going to the right forever again, so it's negative to positive infinity, and that's going to be the case for all your exponentials. But your range, we got to think about these asymptotes again that we talked about, this imaginary boundary line that this arrow is approaching on this left-hand side. So we're approaching 0 here, and that means we can't just say this arrow points down to negative infinity, because it's not going to. It's never going to reach negative infinity. So we're approaching on this left-hand side 0 as our minimum, but we can never reach him. That's a boundary line. We can't touch it. It's invisible. But we know our function's approaching him, so we're going to use him. He's our lowest y value. We just can't include him. And then our highest y value, again, is pointing upward to infinity. So we're going to say it's 0 to positive infinity. So the asymptote kind of affects this value of your range. Alright, and here's another one. You got an exponential, so we need to talk about our asymptote sum. I'm about to write the word asymptote. Alright, so as far as x values go, we're still pointing all the way to the left and all the way to the right with arrows. We're going from left to right as far as we can see. But now we're approaching this as my asymptote, y equals 2. So there's my new boundary line. So again, as far as a lowest y value, we're not going to negative infinity. This arrow over here does not point all the way to negative infinity. We're approaching our asymptote, which is 2, but we can't ever touch it, so we're going to put a parenthesis around it. But on the left-hand side, our highest y value that we're pointing to is going to go all the way up forever, so we're pointing to positive infinity. Alright, so here's your practice problems. Pause the video and just see if you can sketch out the answers for these, and when you're ready, unpause it and check. Alright, here's your answers. Alright, so on the first one on the left here, we've got an asymptote at negative 2. So notice that affected my range here. And this time, it starts at negative infinity. That's my lowest y value. It's pointing toward negative infinity, my lowest y value. And my highest y value now is going to be my asymptote, but again, we can't touch it, so it's not going to be included in the bracket. The middle one, your line, again, negative to positive infinity for both of them. That's what I told you is pretty much going to be for all lines that have a positive or negative slope. And then this one, you have no arrows, so there's actually starting and stopping points. So this is one of those you can box. So you can say, well, the leftmost x value is -7. The rightmost x value is over here at 6. So it's anything between -7 and 6, which you can include with brackets. And then your lowest y value is at -9. Your highest y value is at 5. And so we've boxed in our function, left to right, up and down. And so our domain range need brackets for this one. Alright, so until next time, keep practicing. Come see me if you need help.